Measuring and Constructing Angles, Lesson 1.3. We have 2 previous videos. If you get lost or confused with the vocabulary or what I'm doing, watch the previous videos that are linked in the description. An angle is a figure made from 2 rays, or sides, with a common endpoint called the vertex. You probably learned this in middle school. So this is the vertex right here, and the plural of vertex is vertices. We can name an angle in several ways. It can be named by its vertex. This is labeled point A, so that's angle A. It can be named by a point on each ray and the vertex. So here we have a point on this ray, A. We have the vertex B and a point on this ray, C. So we could say that's angle ABC. You can also name it by a number. Here, I know this is a little dark, but there is a 1 inside here in the interior, so we could call that angle 1. And the set of all points between the sides of the angle is the interior of the angle. So all of this inside here is the interior. The exterior of an angle is the set of all points outside the angle. Okay? So we've started gathering some vocabulary words here. I want you to remember that congruent means same size and shape, and that's the symbol for congruent. I want you to remember that that's a compass, that's a protractor, and these are the vocabulary words that we're going to be using in this video. Okay? So we're up to here right now. We're at exterior of an angle, and we're going to continue on and talk about these. Okay? So we can name this angle right here. We can name it as B, because that's the vertex, and this is the symbol for angle. We'll talk about this more in a couple seconds. We can also label it ABC. We can also label it the other way, CBA, and there's a little 1 in the center, so we can say this is angle 1. We can't name an angle just by its vertex if the point is the vertex to more than one angle. So here there's 2 angles. We've got this one and this one. So we can't say that this is angle B because we wouldn't know which angle we're talking about. There's 2 angles here. We have ABC and CBD. And the middle point is always the vertex. So we can look at our notation here and know that B is the vertex. B is the vertex. It's the middle one. See? So don't confuse this angle symbol with a less than. There's a difference. The less than symbol is on a slant and then a slant. The angle symbol is flat on the bottom. See that? The measure of an angle is usually given in degrees. And there are 360 degrees in a circle, so 1 degree is 1/360th of a circle. When we use a protractor, that's this guy right here, to measure angles, we're applying this postulate. And it's actually kind of common sense. It says, it's the protractor postulate. It says given line AB, so here we have line AB and a point O right here on AB, all rays that can be drawn from O can be put into a 1-to-1 correspondence with the real numbers from 0 to 180. So what it's saying is, as we draw these rays off this point O, or any point off of a line, there's going to be numbers from 0 to 180 on our protractor, okay? So there's actually inside numbers. If you look, the inside numbers go from 0 at this point all the way around to 180 to this point, and the outside numbers start at 0 at this point and go around the outside to this side to 180. We're going to talk about that more in a second, okay? We can use this protractor postulate to help us classify angles by their measure. The measure of an angle is the absolute value of the difference of the real number that the rays correspond with on a protractor. So let's take a look at this absolute value of the difference. We've got this line, AB. We've got this point right here, O. And we've got a ray, OD, and we've got a ray, OC. If OC corresponds with C in this equation, and OD corresponds with D in this equation, we can say the measure of angle DOC, here's DOC, so it's this angle right inside of here, it's equal to D minus C, the absolute value of D minus C, or the absolute value of C minus D. So what they're saying is, let's look at where OD is on this protractor. If we look, it's in between the 110 and the 120. It's at 115 degrees. OC is in between the 40 and the 50. It's at 45 degrees. We can find this angle by doing 115 minus 45. Or, because it's absolute value, we could do 45 minus 115. It's still going to give us the same amount, okay? Because it's absolute value, there's no negatives, right? So we do 115 minus 45, and we get 70 degrees. So we know this angle right here is 70 degrees by using this, okay? We have types of angles. We have an acute angle, so it's cute, it's little, that's how I think of it. It's more than 0 and less than 90 degrees. So could it be 0.5 degrees? Yes, that's more than 0. Could it be 0.1 degree? Could it be 0.01? Yes, it's still more than 0, okay? And it can go up to 89.999, right? Because it's still not 90. A right angle has a little box in here telling us it's a right angle, and it's exactly 90 degrees, like the corner of a paper or a box. Obtuse, because of this OB, I just think obese. So I think that's the big angle, okay? It's more than 90 degrees and less than 180 degrees. And a straight angle is like a straight line. It's made from two opposite rays, so we've got one heading to the left, one heading to the right. Here's the point. And it's exactly 180 degrees. It's so open that it made a straight line, and it's 180 degrees. And we can find the measure of each angle. Then we can classify them as acute, right, obtuse, or straight angles. So here we've got a straight line here, a straight angle, AE, and it's got this O that has rays coming out of it. So if we look at this, we can figure out what the degree is where each of these are crossing on the protractor's measure, okay? And we can figure out if the angles are acute, right, obtuse, or straight angles. So here's an angle, here's an angle. If we put these two together, we'd have COA. That would be an angle, wouldn't it? So we can put a couple of them together, and then you ignore the ray in the center, and then that's the angle. We have EOC or COE. We can say it either way. And the measure of angle AOD, here we have AOD, so that's this really big open angle here if we ignore these two guys in the middle. We would write it with an M, and then that angle notation, and then the AOD. So the M means measure, and this little symbol means angle. We have measure of angle AOD. Okay? So the measure of angle AOD is 165 degrees. We're starting at this line here, and we look over here, and we see that it's in between 160 and 170. It's 165 degrees, and by definition, it's more than 90 and less than 180, so it's obtuse. The measure of angle COD, we have COD. This D was at 165, wasn't it? We saw that from here. We look at C. Where is C located? We see C falls between 70 and 80, and my marker was thick, so it's not quite perfect, but it was 75. So what we do is we take that 165 and we subtract 75. The absolute value is 90. So we know that COD is actually a right angle. Okay, we could even put a box there if we wanted to. The measure of angle BOA, here we have BOA, so it's this one right here. We start with this line A as 0. We look at where the B is, and it is between 30 and 50. It's right on the 40 line, so it's 40 degrees. And by definition, because it's 40 degrees, it's acute. It's more than 0 and less than 90, isn't it? And our last one, the measure of angle EOA, well, that's 180 degrees, so it's a straight angle. We look at EOA, and it's this line along the bottom here. It's this straight angle, okay? Now, I wanted to show you one more thing, talking about these angles. before we continue on. You take a piece of paper, any piece of paper or the corner of a box. It's going to have a 90-degree right angle. Okay? If we fold it directly at the corner, nice and pretty, and we can fold it in half like this, then this is 45 degrees and this is 45 degrees because we split the 90 in half, see? So that's a 45-degree angle and that's a 45-degree angle. We can actually fold it carefully into 3 sections instead of 2 and do 30 degrees, 30 degrees, and 30 degrees, couldn't we? Okay. Congruent angles are angles that have the same measure. So here we have 2 angles here. They're different labels. We could say this is angle B and this is angle E. There's arc marks. Here's one here inside the interior and here in the interior. Those curvy marks, those are arc marks, and they show that the 2 angles are congruent. We can say the measure of angle ABC is equal to the measure of angle DEF. That means angle ABC is congruent to angle DEF. We read it like that. Angle ABC is congruent to angle DEF. We can construct congruent angles. Here we have angle B. We can make an angle that is congruent to angle B. We use a straight edge to draw a ray with endpoint E. Because we're making a congruent angle, it's going to have different labels. So we make our straight edge line like this. We make a ray with the endpoint E. We put the compass point at B, the original one, and draw an arc right here. Just like this, okay? So what we're going to do is we're going to take our compass, we're going to open it up, and we're going to make it any size arc that fits this, and we're going to put our point here and just go like this and make an arc, okay? So we put the point, we make our arc, all right? And we make sure that it intersects both sides of angle B, this ray and this ray. And we label the intersection points A and C. We can label it anything we want, but I'm just using ABC, okay? So now we have this point and this point on our original angle, okay? We use the same compass setting. We don't open it or close it anymore. And we place the compass point at E on our ray, okay, that we drew. And using the same opening, let's see if I can do this with one hand. All right, so we're about right here. We drew the arc. And on our ray, we do the same thing from E. We draw a nice big arc. And where it intersects the ray, we make point F. We label it as F. And we put the compass point at C on the original one here, and we squeeze it down. Let me see if I can do this with one hand. We squeeze it down so that it's the size of the angle right here from A to C, okay? So we put it on C, and we measure where A is, all right, on the original one, to find the distance of AC. So that's the distance from A to C. We put the point of the compass at F on our ray that we drew. So we're going to put it right here, and we're going to make an arc just like this. See? We draw the arc, and then we label its intersection with the first arc as D. So that would be point D. Then we use our straight edge to draw a line from that intersection, that point, to E. And we now have a congruent angle to B. Just remember to show all your construction arcs when you're doing this, okay? I have another postulate for you, and you should be writing these down in your spiral or your notebook because we're going to be using these in proofs in the future. This is the Angle Addition Postulate. If S is in the interior of angle PQR, so let's find PQR. Here's P, here's Q, here's R. So S is in the interior of this big angle, isn't it? Then the measure of angle PQS PQS, this green one, plus the measure of angle SQR, this red one, is going to equal the whole thing, PQR. And this postulate is a lot like the segment addition postulate from video 1.2, where we said if you have a segment and you add another segment together, then they're going to equal the whole thing. And we can use the angle addition postulate to find the measure of an angle. So here it's given. That means it's information that they're just handing to us, okay, that we can use. The measure of angle ABD is 37 degrees. ABD, inside of here, is 37 degrees. It also tells us the measure of angle ABC is 84 degrees. ABC. So the whole thing is 84 degrees. It wants us to find DBC, this inside of here. Well, common sense tells us if the whole thing's 84 and that's 37, we could just subtract, couldn't we? So using algebra, we say the measure of angle ABC is equal to the measure of angle ABD plus DBC. These two together, right? That's what the whole thing would equal. We know that ABC is 84. We know that ABD is 37. And we have the measure of DBC over here. That's our equation. We can use additive inverses and do a negative 37 on this side and negative 37 on this side. That creates a zero pair here and eliminates it. We have 47 degrees on this side equals the measure of angle DBC. So we know that's 47 degrees, okay? And when using a protractor, angles open to the left use the outside angle. Sorry about the focus there. If it opens to the left, we're going to use the outside measures on the protractor. If it's opening to the right, we're going to use the inside measures. So if we take a closer look at this, this one's opening to the left. This is a 55-degree angle using the outside measures. It's at 55 degrees. Can you see that? I'm having little focus problems here. Okay? And if it opens to the right, we can use the inside measures. This is a 55-degree starting here, see? All right? So depending on which side the angle opens is going to depend if you use the inside or outside measures on the protractor. An angle bisector is a ray that divides an angle into two congruent angles. So this pink line here is a bisector, and it's splitting this 90-degree angle into a 45-degree and a 45-degree. We can construct the bisector of angle A. Here's angle A. We put the point of the compass at A and draw an arc, just like we did before with the other one. Let's see if I can do this with one hand again. All right, so here we've got our compass, and we put the point of the compass at A, and we make an arc, okay? We're just going to go like that, okay? And we're going to make intersections B and C. We use the same compass setting, we don't move the compass, and we draw intersecting arcs from points B and C. So once we make this arc from A and go like this, we're going to put the point on C and make this arc, and put the point on B and make this arc, see? And we can label that as D. We use a straight edge to draw ray AD, right down the middle, dead center. So ray AD bisects angle A. We just want to make sure the compass is tight and won't move easily. If you look at the compass, there's screws on here, or a screw I should say, right here. And if it's really loose, you can tighten that screw so that it doesn't move too easily. Okay, so you have more control. All right. We can find the measure of angle ABD with algebra. Here we've got this nice drawing right here, and we've got a big angle ABC, and we've got this bisector BD. And remember, bisector goes dead center, so that means if this is the bisector, the size of this angle is identical to the size of this angle. And it's telling us, it's given that ray BD, that bisecting ray, bisects ABC, ABC. It's telling us that it does that. So knowing the definition of a bisector, we know they're both equal. Well, if the measure of ABD, this top one here is 6x plus 3, and the measure of DBC is 8x minus 7, and we know that they're equal, we can set our equation. So 6x plus 3 is equal to 8x minus 7. We find x. We can start by adding 7 to both sides to make that a zero pair and eliminate it. Now we have 6x plus 10 equals 8x. We can get rid of this 6x on this side by adding a negative 6x to both sides. Now this is a zero pair and it's eliminated. We have 10 equals 2x. We divide both sides of the equation by this coefficient 2. That makes a giant 1x. So we have just x here. And 10 divided by 2 is a 5. We know 5 equals x. Now, knowing 5 equals x, we can plug that in to one of these expressions and find the measure of ABD. ABD. So it says it's 6x plus 3, but it wants its degrees. The measure of ABD equals 6x plus 3. If x equals 5, we have 6 times 5 plus 3. It's 33 degrees. See? Now, what if it was 1/6 plus 3? Well, we could multiply it by 6, because that's the denominator. We can convert it from a fraction to a whole number. If we multiply this expression by 6, then we're going to have 6x plus 18. See? We multiplied the terms by 6. That makes a 1x, doesn't it? That's just an x. We have x plus 18. So if you come across a fraction and it's difficult, know in your heart that you can multiply it and get rid of that fraction, okay? And work it as a whole number. If you're doing a problem like this and there's no drawing, try making a drawing to clarify the problem for yourself. It'll make it easier if you can visualize it, okay? Our next lesson is pairs of angles. That's lesson 1.4. So I know these are kind of long, and my hand, I had an accident, so I have trouble with my hands and arms, and the videos start to shake. So I'm thinking of making these a little bit shorter and breaking each lesson up like I did with the algebra ones. So I hope you're doing well. I hope you understood what I talked about. I hope you have a great day, and I'll see you next time. Bye.